Hello everyone, welcome back to my YouTube channel, and today is the third lecture of this series of electric vehicle. Guys, I have one important update for you all. If after the all sessions, all lectures of this series, we will conduct a examination, online examination. If all of you or any one of you will qualify that examination, we will certify you. We will give you the certification of training. So don't wait for any other thing. Take your copy and pen, just start learning with me. So today we are going to uh, cover the lecture number third, and that is the based on the battery. First part we already did along with the what is the electrochemicals and a lot complete electrochemistry of the cell. That means the behind technology of the battery. And today we are going to cover the second part of the battery. So we have 4 lectures on battery and 2 lectures you will get on 2 or 3 lectures you will get on a battery management system, and one additional lecture you will get for the calculation of entire battery and everything. So let's start it. And if you are new on the my channel, please subscribe it for the update of next lectures. So everyone, and in today's session we are going to understand what the battery is exactly, and some very important terminology that industries are using in terms of communication and all. What are the different types of battery, and how we are going to increase the voltage of cells, and how we are going to connect it, how we are going to make a battery pack like this, and how you will decide the power of the battery, capacity of the battery, and also how you are going to fix the uh, total voltage, required voltage. So in today's session you will get each and everything and some important terms also. So let's start it. So basically this session is based on the automotive like electric vehicles only. So we will cover those application of battery which currently we are using in automotive industry. So in electric vehicles, so where we are using the batteries to power the system. So in hybrid electric vehicles we are using a battery, one battery, and at least one other power source. If you remember, in my first lecture I have covered the type of vehicles, electric vehicles. So what are the hybrid electric vehicles, what are the PHEVs, what are the REVs, and what are the pure battery electric vehicle. That is the only electric vehicles that we are calling the pure battery electric vehicles. So if you don't know these terms, go back towards the first video of this lecture series. And in plug-in hybrid electric vehicles, we are using the larger size of battery than the hybrid electric vehicles. And extended range of electric vehicles, we are using the more larger size of battery than PHEVs. And battery electric vehicles, we have only one power source, that is the battery only. And what the mean of this large size of battery packs? Large size means we have high voltage and high current. Okay friends, let's move ahead for the next one. And this one is what the battery can be classified in majorly 2 types. First one is what primary batteries, and this is secondary, and you all know what the mean of primary and secondary. And there are some subcategories which we did not cover in our last session. So subcategory on the basis of construction and chemical composition, and physical attributes and performance, and voltage, ampere hour, energy, capacity, C rating, charging and discharging characteristics of the battery we will understand. And the most important thing, we need to know what are the various battery terminology that we are using in our daily life and for the electric vehicles. So first one is what battery is what the made up of cells, and battery is a combination of cells. We know about what is the nominal voltage, capacity, that is the C rate, and energy and power of the battery, cells connected in series and cells connected in parallel, because we are making the batteries by combining cells in series and parallel. So that's why these all terms are very much important for us. What is the load and what is the depth of discharge, that is what the DOD. Watts and volt amperes, state of health, that is SOH, and state of charge, that is SOC, and the state of function, that is SOF. So these are the 12 13 terms which we are using in batteries. And let us understand one by one what is the cells actually. The cells are the smallest individual electrochemical unit, okay, and they deliver a voltage, and that depends upon the cell chemistry. That means what will be the voltage, that depends upon the cell chemistry totally. And there are primary means single use, and secondary, that is means the rechargeable battery. So primary and secondary batteries means primary is the single use, and secondary means the rechargeable cells. And a cell is a different from a battery because cell is the single unit, like a cell of this human body. Cell is the what, the primary or fundamental unit of the structure. So here the cells are the primary structure for the batteries. And what is the battery? Batteries and the battery packs are made up from the group of cells. I will explain, no need to worry about how we connected one cell to another, you will understand. And these cells can be wired together in series or in parallel or in some combination of both, okay. And sometimes they are packed in a single physical unit. We can make one battery pack. And like for 12 volt lead acid batteries, what we can do the 6 cell of 2 volt, we can connect them in a series. And other times the connection are external to the cell, means if 12 volt we create this one, another 12 volt we can create, and if we want to make a 14 volt, so we need to connect the both batteries also in order to make a 24 volt. I hope you got it. So that connection will be external. And next part is how we will differentiate this cell versus battery work. How we are going to differentiate. See, cell is the single unit. Here you can see cell is what? Cell is the single unit. Okay. And when we are connecting this one cell, this is what? One cell. And when here is what? Cell number 1 and cell number 2. So if we connect these two cells, that will create a battery. Two or more cells. Battery is what? Battery, you can define battery is the combination of two or more cells. If there is a one single, so that is called the cell. So batteries are cell and batteries, something like that. And what do you understand by the nominal voltage? Nominal voltage means, I will write here the definition so that you can note it down, means the average voltage given by individual cell after charge. Okay. So this is very simple to understand. Cell nominal voltage depend upon the combination of active chemicals used in a cell. For many lithium ion based battery, this voltage what? Over 3 volt, or sometime it is 3.6 volt and 3.7 volt. This is ranging between 3 to 4. And nominal voltage is often printed on the cell packet. कोई भी आप सेल लेंगे, आप देखेंगे उसके पैकेट पे they mention about what is the nominal voltage of this cell. This is important. Suppose if you are making a battery pack, and if they will not mention what is the capacity of cells, every time you need to measure it. What is the voltage with the help of your voltmeter. So nominal voltage is different from the cell voltage under the load, and it is more average or a type voltage. So whatever the lines, you should understand this one is the important, and you can't remember it for a very long time. So you can just take a screenshot, or along with me you can just make a simple notes in your diary. So that will help to get certified from our side. So we will arrange the test that will be based on this entire lecture series. So if you will qualify, you can get the certificate of training. So that maybe take 3 months or 6 months, depend upon my timing also, in how much time I am going to record the entire this course. So if I will take 6 months, so you will get the certification of 6 months of training, and if it will take 3 months or 4 months, you will get the certificate of 3 months, certificate of training of 3 months. But the condition is what? You need to just qualify the examination. And in first time, if you are not qualifying, so you will get the second chance also, third chance also, that to motivate you for the continuous learning of electric vehicle. Okay, so that test will based on the whatever the content I am providing here, and that content is what the industry relevant you will find, because since it's the very initial lectures, so that is quite fundamental, quite basic. When we will keep moving ahead, you will get the advanced things also. So what is the nominal capacity? Cell nominal capacity specifies the quantity of charge, how much charge it has, and it is an ampere hour. We are measuring in ampere hour and milliampere hour, and also a cell is rated to hold. Nominal capacity is also often printed on the cell package, and you can see it. And the next one, we will understand what is exactly the C rate. C rate is the relative measure of the electrical current. Okay, and it is the constant current charge or discharge rate that the cell can sustain for 1 hour. That means what? In 1 hour, how much cell is getting discharged or it is charged. That defines the C rating of the battery. And for an example, you can take, if 20 Ah cell should be able to deliver 20 ampere for 1 hour or 2 ampere for about 10 hours. Okay, and this relationship here, I mentioned that the relationship is not strictly linear, that may be vary and depend upon some conditions, temperature and pressure condition especially depends upon the temperature, that may vary. And here with the help of this graph, you can understand how this voltage versus time graph is there, how it is behaving like, and how terminal voltage versus time. And here you can see the time versus SOC, that is the state of charge, and this is what the state of charge versus time graph. And here you can see the cell current versus time graph, and this is cell power versus time graph. And in each graph, apart from this, you can see up to the certain time, you can see the current is constant, then suddenly it is increasing. Here you can see the time versus power up to 1500. That is what the power is constant, then it is increasing, something like that. What is the energy and power? What do you understand by the energy and power of battery? A cell stores energy. Cell क्या करता है? Normally सेल होता ही है एनर्जी स्टोर करने के लिए. सेल इज अ डिवाइस विच कैन स्टोर चार्ज एंड एनर्जी, and in electrochemical form, energy in electrochemical form, which it can later release to do work. That means releasing of charge or releasing of energy is also very much important. Suppose ये चार्ज तो ले रहा है, लेकिन ये डिलीवर नहीं कर पा रहा है जब जरूरत है, so that means that will be useless again. Why we will store the charge here? So that will not act as a battery. So releasing the energy or releasing the charge for the certain work is very much important. And the total energy storage capacity of cell is roughly its nominal voltage, and multiply by its nominal capacity, which we can like megawatt hour, watt hour and kilowatt hour. The nominal energy storage capacity of 3.7 volt and 1.9 Ah battery will be around 7.303 watt hour. Okay, and how we can get it? We can simply the multiply of voltage and capacity, means P is equal to what? V into I. Okay, so V is what? 3.7 and I is what? 1.9 Ah. So what you will get? Multiply 3.7 and 1, you will get right 7.03 voltage, if my calculation is not wrong here. Okay, you can cross verify it. The energy release rate is cell instantaneous power. Okay, at which rate the cell is releasing the energy. Now let us understand what will happen when cell is connected in series. Suppose you have one cell with the capacity of 3 volt and you are looking for 12 volt of the battery pack. So what you need to do, how you will make 3 volt to 12 volt? You need to connect 4 cells in a series. Series means is what? You are connecting the plus terminal or minus terminal to each other. Okay. So plus minus to plus or plus to minus. You are getting the series connections. Plus minus plus minus plus. You are getting the series connection if they are connecting something. Got it or not? So in this order you can increase the voltage of your battery pack. So when cells are connected in series, the battery voltage is the sum of the individual cell voltage. Suppose 4 cells are here connected in a series. So what will happen? What will happen about this? This one is 3 volt. So 4 will be what? 3 into 4. So that will be 12 volt. We can get easily. And however, the battery capacity is equal to the individual cell capacity, and since the same electrical current passes through this combination of forces, that means the capacity of battery will not impact when we are going to connect the cells in series. Remember, I am repeating it. The capacity of battery will not change in terms of H when we will connect the number of cells in series. Okay, let's move ahead. And what is the like a connection you can understand here? Already I explained, but with the help of this calculation you can understand. Suppose we have this, suppose this one we have one cell, and this one is what? Second cell, and this one is what? Third cell. And you can understand this is plus, this is minus, plus, minus, something like a plus and minus. So minus of this terminal is connected to the plus of this, and the minus of plus of this terminal is connected to the minus of this, and further you can do the same thing. So suppose we have 3 volt, we have and 10 Ah cells in series we have. So what will be the nominal voltage? Nominal voltage of 3 means 3 volt of one cell, and 3 cells are connected. So 3 into 3 will be the 9 volt will be the what? Nominal voltage of this battery pack. And nominal capacity, what will be nominal capacity? So since capacity will not change when we are connecting the cells in a series, so that will be the 1 into the capacity of one cell, that means 10 Ah. So you will get the what? The 10 Ah as a capacity. Nominal capacity we are calling it NC, and the nominal voltage that we are calling it NV, that will be the 9 volt. Okay, and what will be nominal energy we are getting? So we will multiply this nominal voltage energy we are getting. So we will multiply this nominal voltage 3 into 3 into 3 and multiplied by the Ah. So 3 into 3 into 10. So we are getting 90 watt hour will be the nominal energy capacity of this battery pack, small battery pack. I hope it is clear for you. Okay. And what will happen when cell connected in series? Now it comes to increase the capacity of the battery pack. So when cells are connected in parallel, the battery voltage is equal to its cell voltage. Okay, that means voltage will not change, and however the battery capacity is sum of the cell capacity, since battery current is the sum of all currents. So let us see the circuit here, how we will do. So suppose we have 5 cells here, we have 5 3 volt cells, means this capacity of one is 3 volt, 3 volt, 3 volt, 3 volt and 3 volt. These 5 are, and here you can see, suppose if this one is plus 1, this one minus, plus minus, plus minus, plus minus, plus minus. So what we can see? We can see here plus terminal is connected to the plus, again this plus is connected to this plus is connected to this, and this plus is connected to this. And here we can one more thing we can note, the minus terminal is connected to the minus one, this minus to this one, this minus to this one, and this minus to this one. So we are connecting plus terminals and minus terminal for getting this output. So nominal voltage we will get 3 volt and nominal capacity we will get a 50 Ah. So if we are adding the battery as cells in order, suppose here you can see we have had 3 batteries in a series and then 3 batteries in here you can see the 3 batteries 1 2 and 3 batteries in a series, and behind that you can see the 3 batteries also in parallel. So 3 parallel, that is creating, suppose one is what 2.5 Ah. So 2.5 Ah into 3, that will be the capacity, and 3.7 is 1 volt, 1 volt of the cell. So 3.7 plus 3.7 plus 3.7 will be the voltage of this, and 2.5 plus 2.5 plus 2.5 will be the current. So this battery pack you can multiply and add, and just message me what is the output of this battery. So here nominal capacity we can calculate easily, that is 50 Ah, and nominal energy how we will do, we will simply multiply the current number of cells here, that is 5 phase voltage of one cell, and then capacity of the cell. So here we will get 150 watt hour. And friends, let's move ahead for the next one. And here we have the specific power versus specific energy of certain. So in lead acid you can see this is a weaker one, and here nickel cadmium, this is also weaker one. Here you can see the NiMH, and here lithium ion you can see that it is up to the best level, and lithium metal ion, right? So specific power is what, specific power and specific energy of this one is what, the average of lithium ion is what, best one, because the preparation and the investment and the cost, this is affordable. Okay, and now let us understand what is the lithium ion batteries here. I already explained this. We have this positive electrode, we have this negative electrode. Okay, we have negative electrode, and this here between them, this is the what, electrolyte, and this one is what, the separator, and this is what, lithium ion is there, and we have connected these two terminals with the help of one load so that we can find whether current is flowing or not. So the process is simple like a galvanic cell, which I explained in my previous video. Now you can move ahead with what are the parts and their working, that is important. Sometimes, so we have positive electrodes, let us understand what are the things. Means when we are making the positive electrode with the help of lithium cobalt oxide, so what is the advantages of that? And when we are making lithium nickel oxide, so what will be the advantage of that? When we are making a lithium magnesium and lithium iron phosphate, lithium nickel manganese cobalt oxide, and NMC, that is lithium nickel cobalt and aluminum oxide. So what will be the advantage of using these positive electrode with the, of lithium cobalt oxide or lithium nickel oxide? So a positive electrode, if we are if we are using this positive electrodes here, positive electrodes of lithium cobalt oxide LiCO2. So this is what first developed by Sony in 1991. Who developed? Sony. अरे भाई कैमरा वाली. And high energy dense battery density is what, high. Poor thermal stability, this is the one problem, but must be monitored during the operation. Okay, heating problem hai. And limited availability of cobalt is not so much available in the world, so we need to find some alternate, and used in the Tesla Roadster. Okay, let's move ahead one. And if positive electrodes we have like lithium nickel oxide one, so what, this was recognized as the promising material for high voltage batteries, that is better for high voltage, and difficulties with its use, especially for the formation of a salt passivation layer, and contributed for R&D of the lithium nickel manganese cobalt oxide. सो इफ वी विल, अगर ये बना नहीं होता तो नेक्स्ट वर्जन इसका बनाने में बहुत दिक्कत आती है. सो प्रॉब्लम्स आर actually very important. Problems are important for the, especially for the research people. They are seeking always, they are looking for the problems only so that they can work on it and solve it. यही तो बताता है कि हम इंजीनियर हैं. If we are looking for the problems means we are engineers. And what the other things that we can see here. I thought laptop थोड़ा डिस्चार्ज हो रहा था तो मैंने चार्ज में कनेक्ट कर दिया. And positive electrodes, if lithium manganese dioxide or LiMn 2O4, and this one is what forms a three-dimensional spinor structure, that is giving the advantage, and lower internal resistance and improved current handling, and fast charging and high current discharging. So fast charging is the advantage. We can get a बहुत कम समय में हमारी व्हीकल चार्ज हो जाएगी. एंड बेटर थर्मल स्टेबिलिटी बट लोअर कैपेसिटी एंड लोअर लाइफ स्पैन. तो करेंटली हम लोग इंजीनियर्स क्या देख रहे हैं कि भाई हमें चाहिए, वी आर लुकिंग फॉर द गुड लाइफ स्पैन बैटरी, वी आर लुकिंग फॉर द हाई चार्जिंग रेट ऑफ द बैटरी, वी आर लुकिंग फॉर द less discharge rate for the battery. So this is what we are looking, and this is what the availability in the market. So there is a lot more things to do. And positive electrode support, if it is made by the lithium iron phosphate, so what is the advantage? Good electrochemical performance with the low resistance. First thing. Second one is what? High current rating and long cycle life. So that is also very much important, and good for that. Higher tolerance of heat. Okay, that is one of the best advantage. And balancing issues due to high self discharge than other lithium ion batteries. So that is one problem, and very popular in nowadays, because very small disadvantage is there, but other things are very much promising. And 5 is what? Lithium nickel manganese cobalt oxide. So this is what? High specific energy, power with the high density, and a combination of nickel and manganese, that is making it better and most successful lithium ion system. So positive electrodes are made currently maximum made by this particular process. And now let us move ahead for the next one, that is the positive electrode when lithium nickel cobalt aluminum oxide, that is primarily known as NCA. So this is what the share similarities with NMC like a previous one, and NCA is not as safe as the other listed above. So research is gone in the wrong direction, I think, and require special safety monitoring measures to be employed for use in EVs. And we don't have time and effort to give to use this one. And by the way, who is using this? Tesla Model 3. Elon Musk is a very clever person. He definitely had done something for it. And Tesla Model S, because they are successful cars in the market. So, and what are the negative electrodes? We are making it with the help of carbon based electrode, lithium titanate, and lithium metal, alloy based electrodes, silicon based electrodes, and conversion electrodes. So one by one we can understand what is the negative electrodes. First one is carbon based. So this has relatively high specific capacity, high round trip energy efficiency, that's great, and very abundant, low cost, non-toxic material. So toxicity is a problem in terms of batteries, and if it is non-toxic, carbon based electrodes, non-toxic means it is better. And if carbon react with the atmospheric oxygen, in this case of thermal runaway event, the electrode can catch fire. This is a problem. So catching fire in batteries is very much dangerous, and we already have seen many incidents, in some in Pune and in Bangalore. The vehicle caught fire, maybe because of similar reasons. or also that catching a fire of batteries is also the bad management of battery management system, BMS, I will say. That is more responsible. So second one is what? Lithium titanate. A material forms into a spinal structure like previous one, and counter electrode can be lithium manganese oxide, that is what, NMC. Very high level of safety. So if we are looking a very high level of safety, we can use as a lithium titanate as a negative electrode and use in a mobile medical devices. So mobiles are currently considered the safe device, so they are using, means in mobile and laptops also we are using lithium and batteries na. So we should have a proper knowledge of this. And friends, if you are looking for the complete study material for that, you can just message on this given number. You can just WhatsApp, okay, and give your details, and the team will contact you. And negative electrode, one is what? Lithium metal, very large capacity and lowest negative electrochemical potential, and can possibly decrease the mass of overall batteries by 1/3. So that is also the mass decrement of mass. If mass is what decreasing, so this is impressive. And the short circuit caused by the dendrites leading to the thermal runaway and risk of fire explosion. This is again problem. A research in this electrode option is continuous. People are working to make it better and more better. That is what? Lithium metal. So research is going on, and in some ways people will find out the solution of this problem and this problem. So in that case, that will be better, I think. Okay. So electrolytes, we understand the electrodes of both sides. Now electrolytes, we are using aqueous electrolytes, we are using organic liquid electrolytes, we are using polymer electrolytes, we are using the ceramic electrolytes, we are using the solid electrolytes interface. So one by one we can understand. Aqueous electrolyte means that is the conceptually safer and have lower potential environmental impact. And the second one is what? The restricted electrochemical voltage window. And third one, attempt to the increase this electrochemical window have been made, is still under R&D. People are working, researchers are working to make it better, aqueous electrolyte, okay, to making it more better. And the second one is what? Organic liquid electrolytes. So based on the organic solvent and loaded with a lithium salt, and good electrochemical stability with stability, high lithium ion, and conductivities are needed. Means what? High conductivity is there. And development of room temperature ionic liquid. And when we are moving ahead, that is the polymer electrolytes. So overcome the problem posed by the organic liquid electrolytes. This point is what? Good. And promising alternatives enhance of safety performance of the battery, that is very good. And composite of electrolytes as a gel like low molecular weight, that is also very good. And composite electrolytes a solid high polymer molecular weight properties. So that means in case of anything, this polymer electrolytes are better now up to this point. And here we can say the different type of cells. Cylindrical cell will be look like this, primitive cell, prismatic cell will be look like this, a pouch cell will be look like this, and button a cell something is like this. Very small cell we are using on cameras and other thing. And 6 basic requirement for an ideal battery. If you are looking for a good battery, these 6 parameters should be there. These 6 parameters should be satisfied. The first one is what? High specific energy. Second one is what? High specific power. Third one is what? Affordable price. Price is very much important. If you are looking into the Indian market or world market, the price is very important, playing a very important role. And this is what? Long life. Lifespan should be higher of the batteries, and safety should be there. Safety should be the first priority. And wide operation range means performance should be better and better. Again, I am saying, if you are looking for the study materials and the guidance for the certification and all, you can just contact WhatsApp on this number. You will get the details. And thank you so much guys for your cooperation and support. Keep like, subscribe and share this video to your friends so that they can get this like a benefit of certification after the entire lectures and all. Okay, good luck. Bye.